Assalamualaikum, good afternoon. So we are going to learn about the data structure, which is the array. On this video, we are going to concentrate on the one-dimensional array, which is also known as list. So before we start, we need to know the syntax that normally used to define an array, which is already been defined before when we have this lectures in the early of the subject. So this is the syntax that we use for the definitions of the array, which is the DC and also DS. DS may be a new one for you, but DC had been normally used and have been so many times being used in our programming in the EZ68K, which is known as defined constant, and DS is also known as a defined storage. Okay, so let's look at how the syntax work. This is actually the examples and how you can use the labeling and the command here. So here you can see that you can put the label over here and also the command dc dot size, which is can be byte, the word, and the long word, and then later the values. So this is a example that we have on define constant by using byte, word size, and long word. So again, this is a normal one. You have to declare first your origin, which is this example at 1000, and then you start to define the constant byte for 7. For A, this is ASCII. This one is a different constant W is 100 in hexa. Constant long word in hexa, and this is the end of the syntax. Okay, so you also can use direct additional informations on the data, like for example this one, define constant dot byte. You can just simply put 1, 2 because this is considered 1 byte, this is 1 byte, this is another byte, and this is the last byte in this statement. So it means that you have all these 4 in byte size because of the comma. Okay, next one. For the defined storage, this is normally used to reserve a room. There is no value. This is to reserve a room for variables and not initialize. So defined storage syntax is used. Again, the value the command will be labeling. This is the label first, and then this is actually optional. And then you have the syntax ds.size, which is your W or byte or long word, and how many storage that you want to add times how many. So for example of this one, this is a command that the defined storage example here. So for example here, this is a defined storage dot byte for 2 times. So means that you have 2 locations of bytes, and this is also another one, which is 2. So 2 of them. Word, you have 4, and then this is another 2, means that you are going to reserve another word size over here, and the last one is long word is 16, so its total would be like this. So this is a total how many? Only 1. So total would be like this here. This is 1, 2. This is another 2 because of the word size, and this is actually the long word size. Okay, so you can see that how the numbers is coming from here. So this is starting from 1000, right? So this is actually 1000. You can see that this is 1000 for this storage. Okay, and this is 1000. This is 1001. This is 1001. And next, this is going to be 1002. This is 1002. So you can see that this is going to be here, starting at this command 1002. This is 2. This is 3. This is 4. And this is 5. So remember that each byte is one address. So this is going to be 1006. So you can see that this one is the beginning of this one, which is after the define constant.w. This is a command. So you can see that this is actually how many of the storage have been reserved. But normally, for the example that we're going to work on, we are going to talk about the DC, define constant, over here. Alright, let's try. So this is an example. You can see that how many bytes of storage are reserved in this statement. You can see that this is how the total of 32 bytes example had been reserved accordingly to this particular command. So you can just calculate this one. Very simple. Byte, you have 6 bytes. W, you have 2. How many? 2 is actually 2. 4, 1, 2, 3, 4 is 8. 4 times 2, which is this one just now. This is every word have 2. So this is actually got 8. Right. So define constant dot long. What is it? 22 bytes. 8. So this one is how many? 1, 2, 3, 4. Okay. So 4 times 3 is equivalent to 12. Right. Is it 22? 8 plus 6 is 14. I think got something wrong over here. 4 times 2. 1, 2, 3, 4. This is only 4 only. This is not times 2. This is actually 4. This is 2 times 2 times 2. This one. This is 2 times 2. So total up, this one is 12 plus 4 plus 6 is equivalent to 32 bytes of storage. Okay. Next, so this is actually the real topics in the array, which is we are going to look at the a list. They call it a list, or another thing they call it one-dimensional array. Okay, so what is array? Array is a data structure that contains a group of elements, usually of the same size and data type. Okay, a list or vector, they call it another term they call it is a vector, is a one-dimensional array, whereas matrix is two-dimensional arrays. So in this example, we have two types of matrix, two types of array, which is the first one here. They call it the list, which is a one-dimensional array, and the next one here they call it matrix, which is a two-dimensional array. So how you want to define your array? This is an example of defining this is defining two arrays over here. This is the first array, they call it cards, and the second one they call it suits. So you can see that here is the first array, which is only 5 elements of them, 1, 2, 3, 4, 5, and you have another suits array, which is also defined as constant.byte, which is also have another 5 elements over here. Okay, so you also can define by using defining storage over here by byte. You can see that this is 5. You can see actually it's going to be the same result if you put all 0 here and you just define the storage as 5. There will be no informations or values inside the array. Okay, next one, the two-dimensional array matrix, which is the magic square. This is example, the names of the matrix. The names of the array, which is also a matrix, where it's a two-dimensional array. You can see that the defined constant it will be like this, and you can see that here is the total elements for the array. You can see that the array for the second one is defined on the next level, the next line, not like this one is only one line. So this is one dimensional array and this is a two-dimensional array. Okay, here let's go back to the example for the one-dimensional array. This is the method how to define your array over here. So this is example of an array named cards, and then you have an example array named suits. Okay, so you also can use this syntax also to have the same result for this one, because this is nothing. When you define a storage for the cards and suit for 5 bytes, there will be nothing inside there, but you are actually defining the array for one-dimensional array. Okay, so cards and suits are 5 byte one-dimensional array. Each array represents one row of 5 values. So this is one row, this is 5 value, 1, 2, 3, 4, 5. Okay, this is one row of 5 values. So the specific element, okay, this is what they call it. The specific element access depends on the position in the array, which is called the index. Okay, this is another terms for you to need to understand. So what is index? Okay, for a 5-element array, so this is a 5-element array, right? The index has a range of 0 to 4. So what is index just now? Which is that is the specific element access depends on the position in the array, which is called the index. So the positions of the element specifically is defined by the index. For example, here cards define the constant byte. You have the 5 elements over here, and the range of the index will be 0 to 4, and you can see that the index is actually starting from 0, and then this is the left, the values inside after the defined constant byte. So you can see that it's moving here, index 0 here, index 1, index 2, index 3, and index 4. So it only have 0 to 4. Even though it has 5 elements, the index number 5 is not exist. Okay, next one. So in this program, okay, before you can go to the program, let's try to look how to define by using 68K. Let's look here and the example here. This is example how we want to define an array by using EZ68K. So this is your origin. So this is your cards. With this card, I have this elements value, not 0, 0, 0 like this example. So I have 1, 2, 3, 4, 5 byte size. So you just run this one, no problem. And then look at the value at 1000, because your origin start at 1000. Here 1000. So now you can see from this value, right? It starts as 1000. The first value or the first index, which is 0 index, is 01. This is 02, 03, 04, and 05. So this is a byte size of array defined in the EZ68K. So let's try to look at another example if you want to define a word size. For example, here I want to define an array with the word size. Okay. Here is define constant.w is the same number over here, but now the size is w. So let's run it. View memory. Now you look at the output of the syntax. Now it is actually a word size for each of the values over here. So this is 0001, 0002, 0003, 0004, and 0005. Okay, you can see that here is how you want to define your array with the word size. This is for only the list or one dimensional array. Okay. Next one. Cancel this one. So this is an example how you want to write a code, because there are so many methods or so many ways to write a code. So this example is for you to look at the command how you want to change any value inside the array. So the command that you're going to use is the address register indirect. The syntax is like this. So this command is used to read and write the individual elements of an array. So this is the operand notation, which is a bracket an, comma rn, which is the an is the base address, which can be any of the adjective address, which is the base of the array address. Rn is the index, which is the index in the array that you want to read or you want to write. Okay, so look at the example over here, because this is quite confusing, but it's okay. So look at over here first. Okay, now you want to see here. Okay, cuts origin 1000. Okay, cuts define constant dot byte 1 2 3 4 5. So you are actually defining an array over here 1 2 3 4 5 at location 1000. Okay, now you have your commands at 1100. This is your commands anyway. This is actually the commands that you want to change something inside your array. So this is a new command for you, maybe move address.long hash cuts to A0. So what does that mean over here? Is going to move the address in a long word size of this hash cuts go to A0. So if you look at here, cuts here, this is the name, and where is the locations over here? So this is the address base, the base address for the array for the one dimensional array. So the base address now is going to be this one, which is 1000. Okay, so this is the base address. Let me try to look at the is this 68K? Okay. Then the next one is to move dot byte index. Index is defined over here. This is your index. Just you define anything from 0, because this is how many? This is 5 elements, 0 to 4. You can change this one different constant dot byte this value to any of this value from 0 to 4. Okay, so now move dot byte index to D0. For this example, the index value is D3. So you're going to look at D0 going to be inserted with a new value, which is number 3. Okay, so this is a new value going to C2, sorry, D2, and then this is a command A0 D0 going to D1. You are going to take the value of the array from here, you're going to put it in D1. So for example here, A0 is given as what? A0 is given as like this just now. So A0 is the base address for the array, which is 1100. Okay, 1100. Now go to D0. D0 is number 3 here. So you have to look at the 3, the index number 3. This is 0, 1, 2, 3. So this is the index number 3. And you are taking the value go to D1. So finally you can see that D1 is equivalent to 4. Okay. Next process is to read D2 D2 is going to be saved over here to A0 D0. Then what is going to be happen is A0 D0 will be put to D3. Okay, so let's look at the command over here. Let's run it one by one. Okay, so now let's look at the, okay, let's try. Is there any problem? What got problem over here? I think let me try. Oh, I think it's because of this. Sorry. What is the problem? 1, 2, 3, 4, 5. Okay. Okay. Okay, now we try it. Okay, let's look at the command here. This is the command same in the slides. Okay, let's look at the command here. Now is origin 1100. The index is saved as define.constant.byte. This is the value which is saved at this particular location, 1100. It's just a number, and this one will be used as the index to change the value in the array. So that's next. You have the origin 1000. This is the program that you want to start. You have the cuts, the definition for one dimensional array. Okay, here is define constant.byte 1, 2, 3, 4, 5. And then this is the command to move the address in the long word size from this cuts to A0. So cuts is this one. The address of this cut is this one, 1000 something. 1000 on this is the base address. So now move the byte number 3 to D0. Okay, this is actually coming from D3 to D0. Then you are putting the 1C to D2. Okay, A0 is coming from this one again just now, which is the cut address, which is over here. Okay, and then you have the sorry, this one index D0, and then you have this value go to D2, and then this is the one that you want to change or read. For this example, this is reading the values from A0 to D0. D0 is given as the third number index over here. A0 is the base address for the array, which is 1000 here, going to D1. So let's look at it. So now move the byte index to D0. This is going to be expecting the address, the index number 3 over here. So you can see that 0 is equivalent to 3. Now this is move.byte hash $1C to D2. So you are going to look at the D2 over here. This is actually 1C. And then this is a command for you to read the value, then put to D1. This is the array value, right? So this is A0, which is referring to the base or the starts of the array, and then D0 is coming from the index over here. So now look at the memory. What you already defined as cards is coming from 1000. 0, 1, 2, 3, 4, 5 here, right? This is the same one for the cards, and it's starting at 1000 base address. Now you want to read the value from A0, D0 to D1. A0 is equivalent to the base over here, and then D0 is equivalent to a number index. Example here, define the constant dot byte is 3. So it means that right now you're going to touch one of the component, one of the elements inside the array, which is number 3 is this is 0, this is 1, this is 2, and this is 3. So this is the value that you are going to copy to D1. Okay, this is copied to D1, and then finally you are going to have the D2 go to A0 D0, which is going to write inside the array, and this is to validate back what you have written in the array. So let's try. Here you can see that just now is correct, so right now run. Okay, so this is maybe something I need to improve. Okay, now here look at this one, move address dot long cuts to A0. So you're going to have the address at A0 over here. So it should be what? It should be 1000 because it's pointing to this one, 1000. Okay, now after D0, A1C, A0 index to D0. D0 is number 3. This is copying 1C to D2. This is 1C. And next one is A0, D0 go to D1. A0 is equivalent to the base address for this one. So D0 is equivalent number 3. So the component will be 0, 1, 2, 3. This component number 4 will be saved. Sorry, will be saved. D2 will be saved to A0 to... Okay, hold on. A0, D0 going to D1. And then D2 is going to this one. So A0, D0 is the third index in this one. So look at this one first before you go. So this is still correct. Now we're going to read to D1. So D1 reading 4, which is correct just now. This is a 4. And then D2, okay, this one, A0, D0, move to D3. So right now, sorry, we are going to change this one first. D2, A0 to D0. So D2 is equivalent to 1C. Okay, this is move this one to this D2, and then this value will be moved to the component inside there. So 1C is going to be changed to element index number 4. Okay, this is element number 4. Okay, next one. Okay, now the last one is only to validate the last component. So before that, you just have to look at the output. Here. Okay, move dot byte. So now you can see that the value now have been changed to 1C. Coordinate to the component over here. So the last one is move dot byte A0 D0 go to D3 is just to validate what happened at A0 D0 and then move to D3. So look at D3 now is nothing. So the last value is already copied back to this command to D3, to the data register number 3. Okay, next one. So how in general, how you want to calculate the effective address of any element in byte, word or long word. So this is the formula. Okay, the formula is quite simple. So any elements you want to find the address, you must follow this formula. So the formula is EA is equivalent to base plus offset. EA means the effective address of the array. Okay, so then the offset is equivalent to size times index, where your size will be different if you are looking for the byte size or word size or the long word size, which is 1, 2 and 4, and then you have to mind this one is you are going to uh, multiply with index. This is where you want to find the value using the index, and that this is the formula. Okay, example here, this is the last example and the first and the last example. So this is an array. Okay, the starting address of a word array is 830C. This is the starting address, and you can see that this is a word array. So what is the address of the word whose index value is 5? So you know that the index is something that pointing to the elements, where elements, not the value of the elements, but the elements itself. Just now, for example, 1, 2, 3, 4, 5. Here there are 5 elements. But in terms of array, sorry, in terms of the word size, okay, or the index, sorry, the index will be 0 to 4 only, because the first one is 0 index and the last one is 5 index. Sorry, the last one is 4. Sorry, the last one is 4. The elements is 5. The element is the value of the element is 5 and the index is 4. So right now is the starting address of word array is 830C. What is the address of the words whose index value is 5? Then you know that this is the index value given. The size you know is a word size. And the base is the base starting address, which is this one. So 8300C plus size times index is equivalent. Size is equivalent to 2. The index is 4. Index value, this is value is 5, right? Index value is 5. Index is 5. Sorry, this is index value. Okay, this is index value 5. So this is equivalent to 10 or equivalent to 8. Okay, now you add that this number, effective address, all this one, and then this is your final number. You can see that here, if you use this formula, finally, the address of the element which index value is 5, you can know the exact place accordingly using the formula. So now it's 8316. You can see that here it starts from 830C, and then this is data for the word size. Word size, so you can see that it's by word size. This is word size also. So finally, the value for the address is over here, 8316. This is the address for the index value number 5. So you can play around with this one with byte or long word. You can try to look at the difference address if the array is use byte or long word and word for calculations. So it will be different. Okay, I think that's all for the first topics for the arrays, one-dimensional array for this one. So thank you very much. Hopefully you can understand that how the array is defined by using the Easy 68K.